We're moving into uniform circular motion. Now this is related to what we were doing before, which was two-dimensional motion. We had tossed balls and tossed objects that moved in X and Y. Well, with uniform circular motion, we're still going to have two-dimensional motion, but we're actually now going to concentrate at things that are moving in circles. Okay? And so when I say uniform circular motion, I mean two things. I mean the circle has a constant radius r, so I don't have ellipses or ovals or anything like that. And also that the object is moving with a constant speed. Okay? Now, this is a little bit misleading because we tend to think of velocity and speed as the same thing, but they're not. So consider an object undergoing uniform circular motion. Right here, it has a velocity v1. Over here, a little bit later, it has another velocity. This velocity would be v2. And then a little bit later, v3 is this way. Now, I want you to think about that. Okay? This object is actually completely reverse direction between v1 and v3. It's changing which direction it's moving, which means it's actually accelerating, right? Because constant velocity means a constant speed and a constant direction. And this thing has a constantly changing direction. Okay, so which way is that acceleration? How can I get there? Well, let's take a look at maybe a motion in between. If v1 is here and v2 is here, that means at some point it was here and it was moving in this direction. Okay? Well, how did it get from moving up to moving up and left? It had to accelerate in this direction. And then again, to get from here to there, it had to accelerate in that direction. And then in this direction, and then it'll accelerate this direction, and this direction, and this direction, and this direction, until it gets back to where it started. Now, if you take a look, all those acceleration vectors point towards the center. Okay, and so that is directed along the radius of the circle. It's in towards the center along the radius. Okay, and because of that, we call this radial acceleration, but also because it's directed towards the center, we call it centripetal acceleration. Centripetal just means center seeking. Okay, so centripetal acceleration is the acceleration an object has when it's moving in uniform circular motion. Centripetal acceleration is denoted AC. How do we calculate it? Well, I'm not going to do the math for you here. It involves a little bit of calculus. But the centripetal acceleration, or the acceleration towards the center, is given by the formula v squared over r. And where v is the magnitude of the velocity, and r is the radius of the circle. So checking our units real quick, we can see meters per second is the unit for velocity. If I square that, that's meters squared per second squared, divided by r, which is the radius measured in meters, so that's going to cancel that square, and so I'm left with meters per second squared, which is the unit for acceleration. So this does give me the correct units. You can, if you might look in the book to see how it shows you how to do the math, if you want to see how that's done. But this equation right here, v squared over r, that allows us to calculate the centripetal acceleration of an object, and it's a pretty straightforward thing to use.